Good evening, everyone. My name is Yelena. I'm one of the graduate teaching assistants in data analytics program. So let's go ahead and get started. The purpose of today's meeting is to introduce you to R and R Studio. So here is the meeting agenda. You're going to see what R and R Studio is, and you're going to get familiar with R Studio environment and interface. I'll show you how to save all your commands in a script, how to use variables, how to read data from the CSV file into R, and we're going to learn about the data frame objects. We're going to learn about the filters, data visualizations, and there is a bonus at the very end. There is a bonus for paying undivided attention. All right, so let's move on. Here, this screenshot shows the first 10 rows of the data set that I'm going to use for the demo purposes. And here is a web page where you can read more about this data. And you're going to have a copy of the slides and a copy of the R code that I'm going to use in this presentation. After the presentation is over, you will have a copy. So now let's continue. You might be wondering, what is R? R is a language for statistical analysis and data visualization. It's completely free and it's an open source, right? And it's available for different operating systems, right? So I hope everyone can hear me. We do not hear. Do you guys can hear me? Can somebody type in the chat if you can hear me? So, yes, you can. Yes, thank you, guys. Thank you, thank you, thank you. Thank you. All right. So I just want to make sure. Now, you may save the comments in the script. And the reason we do it is because we want our results to be reproducible. You can share your results with anyone. And there is a very rich, powerful online documentation. And R works really well in the academic setting. You can work with databases, and this is especially in big data course that get introduced. There is more than one way to produce the same results, and R supports parallel processing. Now, of course, there are always some drawbacks, is that we need to put some effort to learn. There is very limited graphical interface, and you need to learn how to read the help pages. R is case sensitive, so in other words, if I type Yelena in all uppercase and Yelena in lowercase, it's different variable, different person. It may not solve all data mining problems, of course, and you need to keep updating your packages regularly, and this is important. In order to install R and R Studio, make sure that you have admin rights on the PC, or at least if you have the admin username and password. Right? This is very important. So now, this is what you need to install, and you're going to have a copy of the slides. You have to install R, and I put a web page here. So somebody mentioned no sound. Make sure you adjust the headphones, and make sure you adjust you're connected to the audio. So here is a web page for the Windows, and here is a web page for the Mac. And this is where you download the RStudio. And the latest R version is 3.4.1. This is the latest R version that you need to install. All right. Now, next slide. Here it's just showing you what's an RStudio. Basically, it's an integrated developer environment that runs on top of R, and it simplifies. And hello, yes. Okay, and basically, it simplifies a learning process a little bit, because there are some menus where you have environment menu and you have a history menu, all right? Okay. All right, so basically, now here you have a source window, you have environment window, and you have the console window. So the console window is basically the window where you may type the commands in the console window, and you see the output in the console window, you see the error messages, warnings in the console window, right? Your bottom right window has the files tab, plots, packages, help, right? That's what we're gonna use. And I'm going to get to it shortly. I'm going to share my screen shortly. Now, very important, R script, and I'll show you how to do that. The purpose is to make sure all the work that you do can be reproduced. Some homework assignments cannot be done in one sitting. So when I do my work tomorrow, I want to be able to return where I stopped yesterday. Or if you need help from the teaching assistant, you should be able to email the code, and the teaching assistant should be able to reproduce the error message that you might be getting. So in our script, you can put all the commands in the sequence. So I'll show you how to create this R script shortly. But before I do that, yes. All right, let me go ahead and share my screen right now. So I'm gonna have and hit share my screen, and I'm gonna be doing the slides that are in parallel. So what I did here was I opened up the R Studio, and this is what it's gonna look like when you install it, except you're not gonna have the user library here, you're gonna have a system library, and I explain to you what that means. Now here, so far I don't see the source window because I have not started writing my script yet. This is my console window, and I can type my commands in here, but the work that I do here is not going to be saved in a script. It will only be saved in a history, right? So let me know, guys, if you cannot hear me, because two people cannot hear me now. You want to make sure that you have your headphones turned on, all right? So, all right, you're able to hear? All right, thank you. All right, so now what I'm going to do, so here, this is an environment. Oh, okay, thank you, Amanda. This is an environment window. Environment window is a window that shows which variables and what you currently have in what you currently have in the memory right now. At this point, it's empty because I have not really done anything. And history is going to track the history of my commands. As you can see that I was doing something earlier today, right? Here I was doing something. So basically, those are the commands that I ran. And if I want to rerun the commands that I ran earlier, this is what I can do. Look. All right, this is what I can do. I can click here. See this? I selected the command. I'm gonna do the to console. If I do that, right, I can just run. So that's basically one way I can use my history. And this specific command, it's a help command. Question mark is a help command, and it opened the help page, right? So this command basically shows me, the options command shows me the different option setting, including the output size, and then if I want to, I can change this prompt, symbol, and so on, right? So that's a history. Now, since I want my work reproducible, look at this. I can go File, New File, R script, right? So basically, R script is a RStudio file. It has an extension .r. Like Microsoft Word files, for instance, have an extension .doc, right? And this is .r. It opens a window with a file name. By default, it's called Untitled, right? So I can type my commands in here, or I can do this to move the commands from the history into the source file, right? I can click here and I can do to source, right? Just an example. But what I did here is that I did a little bit of homework. Before this meeting, I wrote the script already. So I can go File, Open, File, and I can navigate to the folder where I save my file, right? Alternatively, since I had my file open just before this meeting, see this recent files? I can go from recent because I had this file open before this meeting, right? So now let me close the Untitled. I don't want to save it. Here it is. This is a script that I wrote, and I'm going to give you a copy of this file after the meeting, right? After this meeting. So now, everything that starts with a pound here is a comment. I put the comments just to document my code and to help you guys understand what my code does, right? So when you turn in the code for your homework assignment, you want to put comments. They help you and they help the instructor see what you tried to do, right? So the first command, very first command, r.version. This command will show you what version you have installed, right? So this is very important, especially if you are not running the desktop version of R, right? If you're running the server version, perhaps. Or if you want to make sure, like Elena said today, that the latest version is 3.4.1, if you installed R earlier, you want to make sure that you have the latest, right? So that's how you do it, r.version. Alternatively, you can do session info, but that is going to give you a little bit more information about the current session, right? It's going to give you more information. Now here it's showing you which packages, and I'll explain you what the package is, but it's showing you which packages are already loaded in memory when you launch the R version. I'll explain what the package is, I promise. ls, very useful command. It's going to show you what you currently have in memory, and we have nothing in memory right now. And object is another way to list what you have in memory. We have nothing right now. I may use my RStudio as a calculator. To do that, I just type the command 5 plus 9, right, for instance. And yes, very important, how to run the command in the script. There is more than one way. What I can do here, I can put my cursor on the command and I can hit run. Now my command is going to be printed here in the console, and this is an output. Notice that R treats everything as a vector. So number 14 here is a vector of one element. So 1 is an index of this element, one element. And the element numbering in R starts from 1. Some programming languages start from 0. R starts from 1. Now, although I added 5 plus 9, I still don't have anything in the environment because I did not assign anything to any variable, right? Now here, this command is going to print to the screen. Welcome to data mining. Again, notice that this is an array, right? Or vector, rather vector of one element, and this is a string. Welcome to data mining. Now what I can do, I can create a variable x, and I'm going to assign 3. This is an assignment operator. This arrow is an assignment operator. So I'm going to hit run. Now take a look. Value 3 is added to an environment. If I did not have this window, right, if I was not using RStudio, if I was using R, I would not have had this nice window. To check which variables I have in memory programmatically, I need to run ls command. And right now, ls shows that I have one variable x, right? And remember, this is a vector of one element. Here, what I can do here, suppose that I have a lot of variables, and they're large, they're taking a lot of space. And I need to run a very complex algorithm. What I could do is I have an option to remove a variable from memory. To do this programmatically, I run an rm command, and in parentheses, I put the variable names that I want to remove. rmx. See this? X is gone. Now suppose that I have more than one variable that I want to remove. I don't want to remove them one at a time. So what I could do, this is a command that will remove all variables in the memory. So take a look at this. This ls returns a list of variables in the memory, right? So here, list, right, will store the list of variables in my memory, which is taken as an input to the rm command. So this command deletes all variables in the memory. Alternatively, in this window, see this broom? This broom, it can be used to remove all variables in this environment. Another helpful command is data. As you may know, there is a package called datasets. So here, it's showing you which dataset you have in this datasets package. Here, this command, if you run this command, you're going to get a list of available datasets that you have, not only in the data package, not only in the data package, this is in general. So here you're just it's gonna produce a list of datasets and the packages, right? List of datasets that you have. Right, so now you know that some data sets are built in, they're installed with R, right? And later today, in this lecture, I'm going to show you how to read the data set from CSV file. We'll get there. But before that, so this is options. It's going to show you the options programmatically. Another way to see the options is this, tools, global options. Here, this is another way, and it will open another window. And you can, if you want to, you can change the pane layout. You can play around with the fonts that you want to use in the code, how you want the things to display, the background colors, the highlighting, etc. Right? So here, just keep in mind you have options here. Alternatively, you can change options programmatically, right? Here. So you can read the help page about this, right? Now, here I need to talk to you about vectors a little bit. Command C is a combine, right? Vectors are very important because some functions that we use take input as vectors. It could be a vector of color names, perhaps, right? So C command stands for combine, and this will produce the vector of elements 1, 2, 3, 4, and 5, right? This will produce, so let me go ahead and run this, and this will just output to the screen. We have not assigned this to any variable, so that's a reason we have empty environment here, because I didn't do assignment operator. This one in the brackets is an index of this first element here, and it's 1, right? Now what I'm going to do is I'm going to assign the vector to a variable x. Now, here this is another way to create a list of elements 1 through 5. I don't need to list 1, 2, 3, 4, 5. I can just do 1 column 5, right? That's what it's going to do now. So let me go ahead. And right now, I did not get an output here. It's because I used an assignment operator. I created variable x. I did not print this to a screen. To see what my x equals to, there is 2 ways to do it. I can run the print command, right? Print x, right? This is not in the script. But there is a shortcut. This is showing you a shortcut. You can just type X. Run. Oops. So this is a shortcut, right? Run X. Now, remember that this is a vector. Suppose that I want to output only the third element. I put the element number in brackets, right? X of 3, this is going to give me my third element. Some of you may think this is basic, but the basic stuff is important in order to get to the harder stuff. Class command is going to show me the data type. It's showing me integer because all vector elements are integers. Type_of is another way to show the data type. And str command is going to show me the data structure, right? It shows me this is an integer vector. The elements are 1 through 5, and here are the actual values, right? Now, here I can also do I can output y. So, run, right? Oh, there we go. Do you see why I got an error? I did it on purpose. It's because I forgot to define y. So if you receive this error, object y not found, right? So let's look. Is there an object y? Of course not, right? So what I need to do is I need to define it. And here is a command to define it. What I want to happen is that I want my y to contain values from 1 through 5. I want to skip 6 and 7. And I want to do 8, 9, and 10. This is how I do it. I put 1 through 5 like this. I put comma. And I put 8 through 10. This is how you may do it. There is more than one way to do it, but I chose to do it like that, right? Here it is. Now suppose that I want to list only elements 3 through 6. So I put the subset like here, right here, 3 through 6, run. So this is element 3 to 6. And remember, we start numbering from 1. Here, class of y, again, it's going to give me the data type. And str is going to give me the structure. What else I can do is, this is multiplication. This will multiply every single element of y by 2. Right? So we can multiply, right? That's something to keep in mind. And if I wanted to, I could just add a number to it. Now, I'm going to show you the sequences. I want to build a sequence of 10 elements that starts from 1, and I want to increment by 1. Here, I specified only one input parameter. So, what's going to happen is, default is by 1. If I say to give me the 10 elements, and I did not specify anything else, it's going to start from 1, and it's going to increment by 1. So it's going to be numbers 1 through 10. Right? Now, I want to do 2 through 10. See this? I specify start and end number. Right? Here I specify start and end, so that's going to be numbers. It's going to be numbers 2 through 10. Oops. Run. Here we go. Here, I want to start at 2, end at 10, but I want to increment by 2. So, right? This, you may think this is simple, but this will be used as part of the bigger commands, right? Next part is on getting help. This is your friend. This is a help command in R. Here you have a help panel. This is where the R help pages will be displayed. So now, suppose that I want to see my help page for the bar plot command. There is 2 ways to do it. This is a shortcut. I can just type the question mark and put my command name. This is one way, right? So this is a page here, help page, and it shows me this is a bar plot. It's the name of a function. And this is a package name. The functions in R are grouped into packages. So this here, it's showing me when I would use this function it's showing me the input parameters that it takes, and here are default values. So for example, what's going to happen if I don't specify the color, etc. And here I have the description of my input parameters, and I have some examples, okay? Some useful references where you can find some information, and I have some examples here, right? Now, here, this is another way. Suppose that I know that my function contains the bar, BIR. It contains BIR, but I'm not sure how to spell it. So what I can do is a propose command. It's going to give me a list of functions that contain the word bar. So now I'm going to know what I'm looking for, and I can type the help command, right? I can do that. Here, suppose that I don't want to see the help page, entire help page. I want to see only example part. So this is one way where I can run an example command, and I can put what I'm looking for. This is bar plot, and I'm gonna run. And look at this. It's gonna step me through examples. I have to keep on enter. See this, and it's giving me the code, and it's giving me the plots, and I have to keep on clicking through the enter key. All right. So that's one way. Sometimes you get one example, sometimes you get multiple, right? So now here, our site search enables you searching the online help manuals for the commands. So I run this, and it's going to open your default browser. In my case, I set the default browser to be the Internet Explorer. And see this? It opens up the set of web pages, help pages that I might be interested in on the bar plots, right? And your default browser is set up somewhere in the options. It's one of the options. Now what we're going to do here is, next I'll show you how to read files from how to read data from your hard drive. The first step is we need to set the working directory. Working directory is a folder where R will be looking at to start with. When I attempt to open a file, it's a folder where R will attempt to. When I try to open the file, it's the first place where R will try to look at. So what I'm going to do now, I'm going to run this command to set the working directory. But before I do that, let me see what the working directory is right now. Right? By default, it starts here. For some reason, it starts right here by default. But that's not what I want to do. What I want to do is I created a folder on my external drive. I called it F. And I have a folder called datasets, and I want this to be my working directory. Very important, when you receive the copy of this file, you would need to change this. This is going to be a folder on your hard drive where you save the files that I'm going to be using. I'll give you this file, and I'll give you this script. You will have to update this folder, right? So set WD command is going to save what it will do, it will set the working directory, right, where I want to look for the file. So let me run this and see this. Over here, if you look at it here, the title bar of the console window shows which folder is currently set as your working directory. And to see the working directory programmatically, you can run get WD command. So sometimes you may think, it cannot find my files. But in order to debug, to see the reason why it might not be finding your files, you may want to check what your working directory is. Or also you may want to, this command lets you list the files in your working directory. And I have a bunch of files. Oh, this is a good opportunity to show you something. See this here, 1 means this is the first element in the list. Here, 3 means this is the third element, right? Everything is a vector. So this is the third element, this is the fifth element, right? Fifth file on the list. Now, here, I'm going to read the file from the CSV. This is a command. The command is called read CSV. The first input parameter is a file name. It's case sensitive. The header equals true. This means that the first line in my file contains the column headings. I want to read the column headings from the first line of the file, right? Separator comma means the file is CSV, the comma delimited, right? Sometimes it's possible that I could have a file with a pipe delimited and so on. Default is comma, but I would recommend to explicitly type it in, right? You want to avoid relying on default as much as possible. And if you want to learn more about the input parameters, remember this is your friend, (read CSV, right? And you can see the help page for it, right? For some reason, it's showing me read table instead, but anyhow, this is very useful help system where you can find more on which input parameters the method takes, etc. Right? So this is a file name on my hard drive, and this is our data frame. I'm reading it into our data frame. Let me hit run. So now if I look into it here, see this? This is our data frame, and this shows me the environment window here. It shows me the structure of the data frame that I just loaded, the user ID, smoker, drink level, dress preferences. So these are the variables or the fields. Those terms used interchangeably. Those are the fields in the user profile data. Here, you also see the data type. Factor stands for the categorical. Logic, this means that the values are false or true. And I also have the numeric variables, right? So this is a number, continuous number, which is weight, height, right? This is a numeric. Levels means that the valid values of the factor variable. And see this? If you look at it, let's look at the simpler example here. I want to look at something with the fewer values. Like here, see this high, low, medium, budget, high, low, medium. And here, number 3 means that the value in the first data row is medium. See, this is the third level. Level 1, 2, and 3. For some reason, it ordered for me this way. I can change it. I can always reorder, right? I can reorder it programmatically. We'll get to the factors shortly. But I'm just showing you that this shows the structure of the data frame. And I'll show you how to see it programmatically as well. Now, but first, let's preview what we loaded. Here, view command is going to show the data in a spreadsheet view. Let me run this. This is a spreadsheet view of my data, and I can actually play around. I can sort it, I can filter it, etc. So here it's showing me the number of rows, and now it's trying to show rows 1 through 12. That's what it says. Here, those are my column headings, right? So if I was going to look at my CSV file, this is the first row in the CSV file. Now here, these are the values, right? User ID, this is a unique identifier, right? And here are all my variables. I have 12 variables, right? So if you notice that I put the dataset source, but I took a subset. I'm using a subset of variables here. Now, let me show you the rest of the commands. So here, let me go back. This is how you use the first 6 data rows. This is your friend. Head command is your friend. Guys, if you're not speaking, we're gonna stay on mute, right? So head command is gonna show you the first 6 rows. If I did not specify the input parameter, it's gonna display first 6 rows. Let me go ahead and run this, right? The default is 6. I can specify 10. The reason this command is your friend, sometimes you want to preview the results and you want to do it quickly, so you can just do head command. Tail is the opposite. You can see the last 6 rows or the last 10 rows, right? Now, this command, str, will show you the structure. This is similar to what you see in the environmental window. But what if sometimes you don't have this nice interface, right? I recommend that we do both ways, that we know how to do it programmatically. Plus, you want our work to be reproducible, right? So we want to save here in the script. And this is the data frame structure. It shows me number of rows, number of variables, and etc. Right? Class is going to show me the type, which is data frame. Here, this command just checks if this variable is a data frame. Sometimes it helps us debug. Like, for instance, if the error message tells you that user profile is not a data frame, you cannot use this function because it's not a data frame. So you might want to run this command to check if it's really the data frame or if we may have misread the error, something like that. Here, as I mentioned, there is more than one way to do something in R, and let me show an example. There is more than one way to list the variable names. Names command is going to show me the names of variables in my data frame, right? So this is one way. Another way, there is a command called attributes, and this command returns the variable names, it returns a class, which is data frame, and it returns the data. Row names, rather. Row names. There are 138 rows. It just names the rows by the row number. Now, what is this? This output is actually a list. Behind the scene, this is a list, right? So this is another data type that I did not explicitly cover here, but you have some links to videos in the classroom. This is a list where it contains several elements, and each element of a list could be another list, or it could be a vector. Like here, this is a vector of variable names, right? Now, if I want to see only a single element, right? I want to see just the names. I would have to do 1. What is 1? 1 stands for this first element, right? I want to see just name. This is the first element of this list, right? And another way to see the column names is just to type column names. This is another way. Sometimes the output may look slightly different, but there is more than one way. dim command shows you the number of variables and the number of rows, dimensions. Here, this is how you see the number of rows only. You do the nrow command, or take a look at this. This here is a list of 2 elements. The first element is the number of rows. The second element is a number of variables, right? So what I can do here is this. I can run dim of 1. So what this will do is it will show me the number of rows, right? This will show me the number of rows. Here we go. Now, if you notice here, it shows 1 through 12 here. So I want to point out something because sometimes, to make sure that people don't get confused, it shows 1 through 12. It's because only the first 12s are visible. But if you scroll here, you need to scroll down to see the rest of the variables. Here, see this? It shows 1 through 12. Oh, this is 1 through 12 rows. Sorry, my mistake. This is 1 through 12 rows. And to see the rest of the rows, you need to scroll down, right? You need to scroll down here. So here is 17, right? 17 variables. You want to make sure that this output, that this matches. See this? 17 variables, 138, 138, and 138, right? So that matches. This is one way to verify that the command returns an expected result, right? There is more than one way to obtain the result, and you can just compare. So encall is another way to see the number of variables. Length is another way to see the number of variables. And dim of 2, right? It's the second element here of the output from the dim command. And yet, see this names command returns all variables, and we can take the length of it, right? So this is another way. Because names command returns a list of variable names, and we take a length. Next thing is the descriptive statistics. What is descriptive statistics? It's going to show me, if the variable is a number, it's going to show me minimum, maximum, right? This is descriptive statistics. So let's go ahead and run the summary command. And I'm going to put, here I put the name of the data frame. So that's going to do the summary for every single variable in the data frame. So I need to increase the window size just by drag and drop, and I can scroll up a little bit. So now let me show you something here. See, I can see this user ID. This is not going to be really helpful because, see this? It's showing me that there are 132 unique values, right? It's a unique identifier. Here, it's showing me this variable. I have here the values are false or true if an individual is a smoker. It's showing me the values and the number of dataset rows that have each value. That's what it does. So we have the number of, we have 109 non-smokers and the 29 smokers. So that's basically breaking down it's breaking down how many instances in the data have each value. Now here I've got my numeric variables, and probably the good example would be the weight. Weight is a good example. This is the minimum weight, the lowest weight, and this is the first quartile, median, mean, third quartile, maximum. And A stands for the missing values. So here it's showing me that I have one row where the weight value is missing, right? And we're going to do missing values today, I promise. So now, suppose that I have a huge data set, and I have 200 variables in it, and I only want to see the statistics for just one variable. What I have to do is, I have to put this $sign and a variable name. It's a $sign followed by the variable name, right? This is how you access a single variable of the data set. So this will show me only the statistics for this weight variable, right? Apply is another way to show the statistics for all variables in the data frame. What apply does is that it applies the specified function to all variables in the data set. It's going to look through all, in the data frame, it's going to look through all variable, and the output is going to look different from the summary command. See, it's a little different layout, right? So there is more than one way, and the output will be slightly different. Now, suppose that I only want to know the minimum birth year, for instance. So I can put the minimum here, and I can put here is the data frame name, $, variable name, right? Here we go. Now, if I want to see minimum and maximum, there is a range. Range command is going to give me minimum and maximum. Keep in mind, this will work only for numeric variables. This is not going to work for the categorical variables. Now, here is a standard deviation. If you notice, the summary command does not have this. So this is additional. You can run the standard deviation, and you can run unique. Unique is showing you the unique values of activity, so that's something similar to what levels will do, right? This is levels. Now here is just showing me this is another way. I want to see the maximum. I want to see the maximum birth year for activity, right? So this is what aggregate command does. I not just want to see the maximum birth year, perhaps. I want to see it by activity. So see this? This is what I want to aggregate. Then I put this little tilde, and here is a field that I want to use for my grouping, right? This is what I want to do for my grouping. Next thing here is a subset. So I have the data frame, right? I want to access the individual element of the data frame. You need to specify the row, right? The row number or the row numbers range if you want to access more than one row, right? And the columns range. Like this example might be the easiest one to show. If I want to output first 5 rows, and I want to show only the first 6 columns, okay? So I run this. This gives me 5 rows, 6 columns. It's going to start from the first one because indexing starts from 1. Here, you may notice that here the numbers after comma are omitted. If here you don't see anything, then the output will include all variables. If it's left blank, it will include everything, all variables here. Sometimes you want to see 5 rows and all variables. This is one way to do it. Now notice that I don't have anything added in here, right? I didn't assign it. I just ran the command for the output. On the other hand, I can create another variable in here, call it new profile, and I want to assign the first 5 rows to it and all columns. So this is an assignment. This creates another variable. Sometimes you may want to, if your data set is large, very large, and you want to test something in a smaller subset, so that's one reason when you would do it. Or sometimes you want to back up your data, so you want to create a copy, something like that. Now here, this is another way to list the first 6 variables, because names user profile is going to return this, this returns the list of variables, right? See this? And here I'm just taking the first 6. That's one way. Here, instead of specifying that I want variables 1 through 6, I'm taking a list. As you remember going back up, right? Here I showed you how to create a list, right? So here is an example where I may use a list. I want to get my column number 1, number 4, number 5, right? So this is one way to do this. Here, suppose that I don't know the column position, but I know the column name. So I can put the names of the columns like this in parentheses, and I have to put the column name in single quotes, right? Here, the rows are omitted, right? So it's going to give me all rows and these two variables. That's what it's going to do. Now here, I explicitly specified the variable name. I want to see the first 4 values of the variable smoker. See that? It's going to be false, false, false. What I did is that this is a $sign, and this is the way to access one variable, and it's going to show the first 4 values, right? Here, there is something called the conditional subcision. Instead of specifying I want a row 1 through 5, I want to pick a row from user profile where birth year is greater than 191, right? So this is what I did here. I say this is a condition, right? Here I'm accessing a variable birth year, right? That specifies which rows I want, and I put comma, and I did not specify anything else. So I want to take all variables, right? Here I can combine 2 conditions. I can say that I want to take my rows where the year is after 191, and the budget is medium. So see this is a combination. And I don't specify anything for the columns, right? So you can combine conditions. Alternatively, you can use OR. Now here, I'm showing you how to add a variable. I'm not really interested in a year. Sometimes I want to calculate the age. What I do here, this is a data frame name, $sign, and this is the name of my new variable. And here, I'm saying, I just want to do 2017 minus birth year. Well, it might not be quite exact way to calculate, but I'm just doing it for this example. For the sake of this example, I just do it this way. Okay, so now I want to verify if the variable in fact got added, right? I could run the str command to preview the structure of my data frame, right? Alternatively, sometimes I want to preview the first 6 rows, right? Do you remember our friend, the head command, right? I can do the head command here. This shows us the first 6 rows. So this command, and see this, at the end I have a variable called age. So it worked, it did what I wanted to do. Now here I can remove the variable. To remove the variable, you set it to null. One way to remove the variable is to set it to null. It's all uppercase. N-U-L-L. Why do we remove the variable? In this case, user ID is a unique identifier, right? So we want to remove it. It doesn't really help us when we build a model. It may slow down some data mining methods such as neural network, as you'll see later on. Sometimes your data set may contain sensitive information such as social security. You want to remove it from analysis. Sometimes you may have a variable where it's skewed or where each instance has the same value. Like, for example, if all people in a subset are from Maryland, so I might not be interested in a state because it's the same for everyone, right? So that's an example. So this is how you do it. You set it to null. Very important, all variable names are case sensitive. So if I type ID in the lowercase, R is not going to know what I'm talking about, right? So let's run this command. This will remove the ID. And if I go in here, I should be able to see it. Oh, wait, did I just misspell it? Oh, did I misspell it? So let's go back here. And no, in fact, did it remove it? So I have to make sure that I spell it right? I have to make sure that I spell it right. Anyway, to make sure, to validate if the variable was in fact removed, you can do this. You can do str and then you can put your variable name, right? And notice that this is a nice functionality. It's when I type it, it shows me the drop down here, so that I can select. It makes it much easier, right? So I can go in here and I want to check. This is how you check to make sure that you removed. And alternatively, you can write the names command. Names command is going to show you the list of variables. So that's another way to verify that the variable was removed. And here, oops, yes. The next thing is I need to show you how to sort it. So sometimes our question is, I want to see 10 shortest people. I want to see 10 youngest people. So to do that, we have to sort our data. Here, I want to sort it by age. So I'm going to create another data frame, and I'm going to call it user profile sorted. Here, I'm taking a subset, but I'm specifying here that order. I want to order my data by the age. I have to put the order function where I specify the rows that I want to select, right? And here I did not specify the columns. It means that I want to select all columns, and I'm assigning it to the user profile sorted. And now I'm gonna preview the first 6 rows. Another thing about R that you can resize the windows, right? You can resize. Oh, and something else I need to show you that you have up and down arrow on the keyboard. Use this command, use up and down arrow to scroll through the history. That's another way. So I want to rerun the command that I just ran. So I hit the up arrow and hit enter. Now, if you look at it here, it sorted my data by age, and it's sorting it ascending. Depending on what you need to do, sometimes you want to sort it descending, and to do that, you want to put the minus sign in front of the variable name. So that's going to do descending, right? So for example, suppose that I'm interested in a 5, in the 10, let me say the most experienced. I don't like to say others. I'm going to say the most experienced people, right? There are 2 ways to do it. I can sort it ascending and then use the tail command to take the last 10, or I can sort it descending and take the first 10, right? Now, suppose that I have, take a look at it. For instance, I have several people who are 87. I want to use another criteria. So if people are the same age, I want to order them by weight. So this is 2 variables. Order, and I put a comma, and I put the second sorting variable that I want to use. Okay? So that's something else. I can put 2, I can put 3, depending on what your business requirements are. Here, something I promised earlier, the factor variables. Factor variable is a categorical variable. It has a fixed number of values, right? Like, for example, eye color is an example, or the skin color, or perhaps there could be the religion is an example too. Gender is another example. Your job position is an example of the categorical variables. Age is a continuous variable. Numeric is because there is no limit, especially it could be 5 years, it could be 10. We don't have a fixed set of values. We can, especially if we allow the decimal point for variables such as weight, there is no limit on number of values that we can have, right? So here, year, right now it's a numeric, but I'm not going to do it in a real life example, but here let's go ahead and convert it to factor, just for the sake of the exercise. So the factor is going to convert every single value as a category. It's going to convert numeric to categorical. But you want to use this only when you have a predefined set of numeric values. Like, for example, suppose that I have job grades 1 through 15. I know that I have only 15, and my data mining method works only with categorical variables. Here, it's safe to treat it as categorical because we know the values ahead of time. We know that we have 15, and each value has a special meaning, right? Now, to verify that the command works as expected, you can run the summary command, and you can see that it's showing me the values and the number of instances with each value. I no longer see the minimum maximum statistics. This is what I see instead. Alternatively, I can run isFactor command to verify, right, that it's a factor. Now here I'm going to show you more examples here. What I'll do is I'm going to create a copy of the profile. I'm going to call it new user profile. And let me take a look at the variables that I have. So I have the budget variable. I have a budget variable with the values low, high, low, medium. High, low, medium. What I want to do is I want to record it. I want to code high as H, low as L, and medium as M, right? So I want to do, or actually, I have them in the wrong order, but well, for the sake of this example, well, let's correct this quickly. I should have it this way. You know why? Because it's going to treat them in the same order. When I want to record this, I want to have this in the same order as original value, because I want high to be H, I want low to be L, and I want M to be medium, right? So let me correct this to make sure you have it fixed in a script that you get. So now let me do this levels, and what I'm doing here, this is an assignment operator. Remember, C is a list. So what I'm doing an assignment, and now I can do the summary command just to show that here I see the number of instances for each value, right? And I can also run the levels command. It will show that those are the values I have right now, right? For the factor variables, we can see the frequency count. We use the table command, and this is the data frame name, $, and this is a variable name. So I'm going to go ahead and run it, and this is a frequency table. The field is a transport, so I have 41 car owners, and I have 15 on foot, and 82 for public. Since I don't have any missing values for that variable, the sum of these three numbers should add up to the number of instances in the data set. Alternatively, I can see the proportional table. I want to see the percentage of car owners, percentage on foot, and percentage public. So this is a prop table, and it takes the output from the table command as an input, right? So you can nest commands in each other. So this is one way. So see the 0, 29, and I could multiply it by 10 to see percentages, but now here this is something else. You can use two categorical variables. What it's going to do is it's going to count the number of people taking different transportations by marital status. So this is called the cross tabulation. So here it's showing me that I have 8 married car owners, 32 single car owners, and so on, right? So I have 0 married on foot. I have 7 merit taken public transportation. And I can also do this, the proportions, right? And I can get more, I can get even fancier. I can round this to the decimal points, and I can multiply it by 100 if I want to see it in percentages. Next section, this is very important. Missing values. Missing value is unknown. It's just not there, and it's represented as NA in R. Now, I have a variable weight, right? And I want to run the mean function, and I'll show you why missing values are a problem. There we go. What's happening? What is the mean of the weight? NA? Take a look at it. It's because this variable has at least one missing value. We have several options here. I can fix it. I can replace the missing value with an average weight value in a column and then run my mean command. Somehow I can do this. Or we can explicitly ignore the missing values in the mean calculation. This is an input parameter, na.rm equals true. False is default. If you run this, it will calculate the mean, right? The summary command that we used before, it ignored the missing values when it calculated the statistics for weight. But the mean command does not. So that's something to remember. I have more commands for you to check if the data set has missing values. So see, this is NA is going to return if the value is missing. So if I do this, if I just run this part here, for every single value, for every single intersection of the column and row, it will return true if the value is missing. It will return false if the value is there, right? So any command, what it will do is it will check if any of this is true. It means that I have at least one missing value somewhere, right? So I know I have at least one missing value. Here, I want to see how many values am I missing. So this is going to do, it's going to count, the sum will count how many truths I have, right? It's going to count this. So I have 2 missing values, but here I can also see how many instances are missing a value. It's highly possible that it's the same row, right? The same row could be the culprit. Or it could be in multiple rows. It could be the same variable. So sometimes it's very important if I want to determine how to handle my missing values. Sometimes I want to know if all missing values occur in the same rows, and maybe I can just remove one row and we are done, right? So now let's see. So this will show me how many instances are missing a value. 1. Why did I get it this way? It's because I'm missing 2 values, but apparently it's in one row. Here I want to know, I want to see the row number. Which command is going to return me the row number where I have a missing value? So that's row number 16, right? So then I could display the 16 rows and so on, right? So I know the row 16 is a culprit. This is how you just do it. Now, here is another way. What this will do, complete cases, it returns the rows without missing values, right? And this is a negation, right? This exclamation point is a negation. So I want to take a subset of a user profile where I have a missing value, right? And I want to take all variables because I didn't specify what I want to take. And I'm going to run this, right? So here is basically I'm showing, well, notice how it wraps, right? It wraps because it does not fit on the screen. See this? Height and weight, those 2 variables are missing a value. Those 2 variables are missing a value. So now we did that, and here this is additional check. Sometimes you want to see how many values a variable is missing. So this will help you determine how to handle. Suppose that you have 200 data rows, and you know that you have 100 missing values. Maybe those values are missing for the same variable, and I can just do my analysis without that variable, right? So it's a lot of decisions, and there is more than one way to handle it. But let me give you some examples. Here, what I'm doing is an a under dot omit. This will get rid of the rows that have at least one missing value. But I'm assigning it to the new variable right now. Right? This is what I'm doing. Or alternatively, I can do complete cases. This is a row selection condition. I want to select the case if it's complete, right? If it has all values, and I want to do all variables. So this is one way. Another way, right? So there are two ways to do the same thing that I just showed you. We could also handle the missing values by replacing with a column mean. Now, this is how you take the mean, and for the mean to work, you have to specify an ARM equals true. Remember, because we want the mean function to ignore the missing values. Here, what I'm doing is, I'm taking one variable, I'm specifying the variable name, and here I'm saying that I want to take the values that are unknown, and I'm going to replace them with missing. I'm going to replace this with a mean, sorry. In some cases, especially if it's a categorical variable, you want to use a special code to track the variables. Sometimes you want to use a designated code for the missing variables. Like, for instance, I want to say the person is 5 foot by default. Or if it's a voluntary survey, somebody did not provide an information such as gender, I can put unknown to represent the missing value, right? So that's one way. Right? I want to set 5. I can set 5, right, to the values that are missing. Here, I can rerun my summary command again, just to verify. Here, wait. Oh, I still have a missing value because I did something, but I never assigned it to the wait variable, right? I have to make sure that I run it. I did not run the command, sorry. I did not run it. So that's the reason the summary did not show it. Now, take a look at it. There are no more missing values. It's gone, right? And I'm going to run the summary for the height. So this is one way to verify that the missing values are gone. You can also do this. You can do the column sum, right? I want to see the zeros here, right? Next important topic is installing packages. A package is a set of functions grouped together. So if you look at it over here, I'm going to go to the packages tab. They're grouped into two sets. There is a system packages, those are system libraries. Those are the packages that come with R installation. When you install R, these packages were in there. The user libraries, those are the packages that you install by hand, so to speak, after installing RStudio. Some data mining methods such as association rules, decision trees, neural network require installing packages, right? So now this command, browse URL, will open the web page with all available packages. Here we go. And my default browser for R is set to Explorer. So that's the reason you see it in Explorer. And I can click on the package name and I can read more about the package. Library command is going to list me which packages I have installed. Now, okay. Oh, here it is. It's going to open another window right here. All right? And some of you might be wondering where is it installed. This is a folder. It might be a little bit different for Mac users, but if you're a Windows user, it's going to have, in the document, it's going to have the R Win Library folder, and then since this is R 3.4.1, you'll see this folder 3.1, and here, each folder, each subfolder in here, it contains the files for the package, including the help files, and the data sets that could come. Some packages come with data sets, so it's going to be in there, right? So now you know where it is stored. And when you install the very first package, you might be prompted to create that folder. Very first package, when you install, you might receive a pop-up. So select yes in that pop-up to allow or create that folder that I just showed you, all right? So let me go ahead and close this out. Something else to keep in mind, the package that you install, like this user library, they're installed, but they're not available because I have not loaded them in memory. So I want to know which packages are loaded in memory. The user library that is loaded in memory is going to have a check sign next to it, right? See this? However, suppose that I don't have this nice window. To see it programmatically, I can do the search command. The search command will list the packages that are in memory programmatically. I never loaded base, but base is the system package. It gets loaded by default when you launch the RStudio. And this shows me the location on the PC, right? It shows me the location of the packages on the PC, so I can run this command. This is the directory that I just showed you. See this here, right? This is a system library, and since you cannot really write in the system files, in the program files, you will be prompted to create this folder on the first time you install the package. This is important to remember. To install the package, you type the command install packages. Here, you type the package name, install arrows. I will not run it right now because I already have this package installed on my computer. I don't want to rerun this command. But this package is not available for use because I never loaded it in memory. And to load the package in memory, I can do library command or I can do require command. So when I run library command, see this? You may see this message here. This is not an error. This message is informative. It tells me that it also loaded package called matrix, right? Because there is a dependency. There is some function in my arrow package that calls the function in a matrix package, right? So that's what basically it's telling. Not all messages are errors. Some messages are just informative, and depending on how you configured your RStudio environment, this may show in red color. Mine shows in blue because it has to do with the options that I chose in the options. So I chose what displays better when I run WebEx and what shows better on screenshots. So now here, to read the help page, another way to read the help page on a package, you can do library command, but inside you put help, and here is the package name. Like I want to see my help page here on a rules package. This is something similar to what I see in the help window, but it's all in the page. It's one page, and it shows me the description. It shows me which methods the package has, right? You'll be using discretization there is a method for there is a function here for discretizations in the rule packages, and there is a priori rule methods. That's what this package is mainly used for. So let me close this out. Let me go back. This will show you the vignette, if there are any vignettes for packages, and it will open the, well, it will open the PDF file. Not all packages have a vignette, but the a priori package does. This is very helpful when you use the a priori rules method. You can launch this and read, right, more about the package and different input parameters. Now here, this is another way. You want to open the web page with links to examples, right? Some packages may have more than one example, so, and here, I'm not going to run it right now, but this will update all user packages that you have installed. Now you're going to get a copy of this file. The touch command will remove the package from memory. It's similar to coming here and unclicking this checkbox, right? Or if I want to attach it again, I can click this checkbox, but I want all my commands to be reproducible. I don't remember when and where I need to click this, right? So make sure that you at least copy and paste the code into the script, because when you return to work, right, after you restarted RStudio, you want to just rerun the code with a click of a button. You can do Control-A to select all code and click Run. You want it to take less time, right? Now this topic is very important, discretization. I need to cover it. So let me go ahead, and I have a copy of the slide here, so everything was planned. So let me go to the discretization. What discretization does is, it's also called the binning. It's a process we convert the continuous variable to numeric, but we want to look at the ranges. One perfect example would be the grade you get in a course, right? When the teacher submits the grade into the MyUMUC system, he or she does not submit 90 or 95 or it's 80. The instructor submits A, B, or C, right? So the discretization would be to make everything below 70 is a F, everything 70 to 79 is a C, 80 to 89 is a B, right? So 90 through 100 is an A. So we are converting we are binning, in other words, right? Some methods, they don't take the numeric variables. They require only they require only the discrete. A priori rules method is one of them, for instance, right? Important, you want to handle all missing values before running the discretization. Discretization function, you may use discretize method, which is part of the rules package I just showed, or you may use cut function. I have to show you different methods of discretization. You can use the equal width or equal interval method. So basically, it does not matter how many people got an A. It does not matter how many people got a B. What I want to do is, I could say, so I have 4-letter grades. The grade ranges from 0 to 100. I can say everything from 0 to 25 is going to be an F. Everything from 26 to 50 is going to be a C, and so on, right? So each interval has an equal width, okay? It does not matter how many people fall into each range, right? Equal frequency is approximately the same number of instances in the interval. So what I could do is, I could take the homework grades and I could say, okay, let's take the top 25% of scores and give them an A. Right? It does not matter what the score is. If 70 is one of the 25 higher scores, then 70 is an A. So it does not matter here what an actual grade range is. I want to have approximately the same number of people in the same range. That's what equal frequency does. But the problem is, well, see, here this is not sensitive to outliers, right? And the other method is sensitive to outliers. Because here, I'm just taking, it does not matter if somebody got the score 0, right? It doesn't matter. That person just falls into the last, the lowest 25 perhaps, right? It does not matter. Here it's very sensitive because it's gonna affect the size of the bin. But equal interval, equal width, it's gonna preserve the data distribution. This one does not. Equal frequency method does not preserve the original. And I can specify the number of bins that I want. Right? There are two more. The cluster, this basically will take random points. So here 5 random points, and it will assign each instance to the closest center. Like for instance, I'm gonna take, if it was a grade, I could take the random points, right? I could say 25, 50, 75, right? And I can say 90. If you're closer to a 90 than to 75, then you're gonna get an A. If you're closer to 75 than to 50, you're gonna get a B. Something like that, right? Here, this is fixed. Fixed would be the first example that I brought up, where 90 and above is an A, 80, between 80 and 89 is a B, so I specify the boundaries I want. So here, in this specific example, I want to take the negative infinity, right? It means that here it means that the first interval is basically below 50, right? Then I want to go from 50 to 60 and so on, right? This is what I'm doing here, and I think there is a typo. Oh no, there is no typo. Because see here, this is the first parent, and this is the variable, the discretization type, and here are the categories. Remember, see the list, right? I'm using it here. So now let's go back to R, and I'm going to run this, and I'm going to create a new variable. Just for this demo, I'm creating a new variable. I'm running this command that I just showed you in the slides. And now I'm going to see the summary, right? I'm going to run the summary. Now take a look at this. Take a look at the output. Here, so here is an interval. I have approximately the same width, but the number of people is uneven, right? Here, well, it's not quite the same, but it's close to the same. And then I've got the clustering, and I have the fixed width. Fixed means I specify. And now the square bracket means that 80 is included in the last interval. The curly bracket means that 80 is excluded from this interval here. Data visualization, this is a nice part. So, you might be wondering, there are a lot of ways to visualize the data. When do I use each? Histograms are good for the numeric variables, and when you want to show the frequency. For instance, I want to do the weight, right? So this should produce, what did I do? Here we go, there it is. This produces, here it's showing me the histogram, and notice that there are no colors, right? It tries to find the number of bins for me, and here it put the title for me. So for at your leisure, you want to do this. You want to write a help command, and you want to explore what you may change. You may change the color, you may change the labels, and so on, right? So now here I can change the breaks. Oh, it's telling me to hit return. Well, not sure where it comes from, but here it is. See this? Now what I could do is I can add the border. Border is blue. Okay, or I can do the color. So here you can explore, and you may also combine multiple input parameters. Like that's what I'm doing here, right? Here I just want to use a shading density. This means that I want to shade my bars, and instead of actually doing the color, I want to do the shading, and this shows me this is the number of bars per inch, I believe, and this is the angle. Here the bar plot, it takes the frequency table. So one way to do that, you can store the frequency table in a variable, right? So this is a frequency table, and then I can do the bar plot for that. Oh, for some reason it's asking me to hit enter, but I think it's because it has to do with the settings that may have been changed when I was running the examples earlier. So to set it back, one way to set it back is to restart R, but I don't want to do that now, or to just go to your options. Now here I want to order my bars by height. So here I put the orders. I want to do that ascending. Right? Oops. Here we go. So this is how you order. Now I can do the horizontal, or I can also do the sorting and horizontal. So this is something for you to play around with, right? Now here, this is a pie chart. Pie chart takes a table as an input, and you want to use the pie chart for when you want to see the categorical distribution. Now here, if this is too small, you can change the margins, or you can do this. You can do zoom in, right? Or you can just adjust the margins, right? But let me do this. This is a box plot command. So I'm gonna do the box plot for the H. Box plots work well when you have the. Okay, so this is a numeric variable. Box and whiskey plot. This is good when your variable is numeric. Now, plot function, it's a generic plot function. So this is what happens when you have a single categorical variable, right? So this is a single categorical variable. It looks similar to bar chart. Here, I can also do the line plot. So type input parameter allows to specify what type of plot I want. L means for the line. By default, it did the bar chart. L is line. Now here, I have two categorical variables, right? So it's going to produce it's going to look like this, like a mosaic plot. It's because I have two categorical. And here, this is a single numeric, right? So let's see what happens, right? So it's a bunch of dots. And here, two numeric variables. Two numeric, right? Here is a little bit on using colors. We're almost there. So colors, it's going to display the colors, available colors here. If I want to do my bar plot, and if I want to specify the color, this is how I do it. There are two ways to do it. I can spell my color explicitly, or every color has a number. I can specify the number. I can go colors. Remember, this is a list, and 640 is an index in a color vector. It's a color index. So there are two ways. There is more than one way to do it, but see this? Oops. See this? I can do it here, or I can use the color number. But sometimes we don't know the color number. We don't want an extra step to check what the color number is, so we can just spell it out. Here, this is a set of rainbow colors, and this is really interesting because I want to use a different color code for each bar. This will do. But suppose that I had more bars than the number of columns, the colors would repeat, like I'll show you here. It will repeat. See this? Violet, red, and then it starts all over. Now, here, this part is a bonus. As I promised, I'll show you. It's a three-dimensional plot. So if you like me, you like to play with graphics, this could be an example. I'm not going to install this package because I already have it installed, but Plot3D is a library that allows you to plot three-dimensional. I'm going to load it to memory. So here, what I'm doing is that I'm going to set my x-axis, y-axis, z-axis, and this is a color, right? So here are my x-axis, y-axis, z-axis, and a color variable. So let me run this. Run. Now what I'll do, this is a scatter plot 3D, and I'm going to pass x, y, z. This is a color. Main sets a title, user profile data, this is a plot title. This is a label for x-axis, label for y-axis, and labeled for z-axis. So that's going to give me the three-dimensional scatter plot. There we go, right? And I can always zoom in to see the bigger view. And I can get even fancier. I can change the angle, right? So these are the polar coordinates. This is a polar coordinate. So it's just gonna look different. And here, yet another way, I can add a grid. So that's basically a matter of playing the input parameters. That's what you saw in a slide cover page, right? And I can add, this is a package that allows me to add animation. So let me load it to memory. Here, I'm loading this in memory. It's still loading RGL package. And here, this command will call this method. Oops. I believe it's going to open a new window. And see this, I can drag and drop. I can rotate this thing here. See? So this is how you would add the animation to it. So now we finish this. Let me quickly go back to the slides. I want to make sure that I covered everything important that I wanted to cover, right? So we covered the working directory. We covered how to clear the files. If you notice that here, there is also options. You can, if you wanted to, you could set the working directory. See, this is a default working directory. This is a folder where R will look at when you start RStudio. You can change that as well. If you want to, you can change it, right? So that's what the slide is trying to show you. You can change. And this is the R version that I'm using, right? 3.4.1. That's where it's installed. So now we've got that. We went over how to read the CSV file. We went over how to preview, right? We did the str command. We also went over the data frame properties, and you will have all these slides, I promise, right? And here are the subsets, right? So you've got how to access the variables, how to delete and add variables. We went over this. We went over the discrete statistics. We went over the sorting, right? So remember it. The sorting, sometimes I want to find the most experienced people, perhaps, right? I want to find 5 people who work here the longest. So I'm going to have to sort somehow, right? Or also sometimes sorting helps me find the duplicates. Like we saw, people of the same age, right? So I had to add another criteria for my sorting. Here, I showed you how to work with factor variables, and we went over missing values, and I just put some options. This list is not an exclusive list, but here are some options to handle missing values, and it all depends on your problem and what you're trying to do and the data set that you're working with. And the packages, we went over this too, right? Here, we went over this command where you can look at the VNet, you can look at the packages that are in memory, you can look at the packages you have installed. So we did discretization today. Here, I put a quick summary when you use each plot, but for pie chart, I need to point out that when you have multiple categories, the pie chart might not be very suitable because it becomes quite difficult to read. So that's something to keep in mind. If it's few categories like here, that's fine, right? You can even go through options and look at how to change labels, how to change the radius, how to add percentages, and so on, right? There is much more you can do. Here, this is generic plot functions, and I showed you some differences that it produces based on the data type. I showed you the three-dimensional one, and you're going to get a copy of the code, I promise. Now, here, this is a list of courses in R. There is a cognitive class web page, and it offers free courses in R. This is online, and it's self-paced. You can watch the video as many times as you want. You get the cognitive class free account, totally free, and you can take Introduction to R, Machine Learning with R, and Data Visualization with R. And Data 650 people, if you're attending this lecture, there we go, using R with databases for introductory data mining class people. This is a preview. This will be revisited in Data 650 using R with databases, so this is advanced, right? So it's possible to use R with databases. This is something interesting to look over, right? So anyway, and R can also be used in Spark. So that's later on along the road. Anyway, so here are additional free tutorials that you might find helpful. Especially, I like the try R because it's a game where you have multiple levels, and to get to each level, you need to get the commands right. So it's like a game. And I like this one, the data camp. There is a free R course. Introduction to R is free. Other courses have the first chapter free, and I believe once a year they have a weekend where they give all free, anything you like, but it's once a year. Here are two groups on LinkedIn, R data mining groups that you might be interested to join in. And sometimes you may find interesting articles posted, so that's something to consider. I put a list of ebooks, free ebooks online, and I put together some web pages that we consider bookmarking. The documentations, this is a good one, R and data mining. It has a lot of useful examples. The current packages, and then this one is frequently asked questions in R. So I guess I have been speaking for a very long time. So now, see, we take turns, right? So now it's my turn to ask if people have questions. I'm going to stop sharing the screen and go back here. So let's see. Okay, now let me take a look at this. Let me take a look at the chart. Okay. Okay. Is introduction to RStudio.R file comes with RStudio? No. This file does not come with RStudio, John. This file is, so the question is if introduction to RStudio comes with RStudio. No, this file does not come with RStudio. This is a script that I wrote before in preparation for this session. And I'm going to give you a copy of this script. It's because I did not want you guys to watch me type. I want this meeting to be productive. So that's a reason I put everything in a script, and then I can run it as a script. I'll give you guys the file. So I'll give it to the instructor, and the teacher will post it, post the file in a classroom. Okay. So yes, I realize that Python has been popular with R, but I would think you may consider knowing both. You may want to know both, right? It actually depends on what you're trying to do and on the business problem you're trying to solve. But for the R Studio, well, basically, it's helpful to know both, I would say. But of course, you're going to be better at the language that you're going to be better at the language that you exposed first. But the reason I like R better is that because there is more than one way to do the certain task. So, but it could be my preference, but it's very helpful to know both. Have you done anything with Julia's language? I'm not sure what the question is. Okay, I'm confused by one of the script reference. David, may I ask you which script? May I ask you which script referenced? David, are you still here? I'm looking at the questions. So would you mind to clarify it? Because will the recording be available? Yes. After this, once I get the recording, I'm going to take the file, upload to YouTube, and I'm gonna give the link to your instructor and all the files, and they're going to upload this in a conference. Okay, so now let me look at this. Oh, this one, W. Okay, I see the question. W sequence provides the following, but doesn't start at 2. Oh, let me see. Let me take a look at this. So the question is, let me share my screen and I'll show you what the question is. Let me see. Let me go in here, share my screen. Let me see what's going on. So here, this is a question. Okay. So now I have to put W. What did it do? Oh, you're right. It starts from 2. Yes. So I may have done something wrong. I'll have to check. Thank you so much for pointing that out. Because, see, one way to do this is this. I want to type this sequence command. I want to type the help command to see it. This, like this here. Oh, it's not cooperating. S. Enter. Sometimes things don't cooperate. Well, it happens. But anyway, if this does not work, I can do this as an alternative. I can type help. See this? For some reason, it was not doing what I wanted to do, so I just type help, right? So here it is. I'm not getting the expected result. So here, from, to, and by. Yes, you're right. I have to use the comma. Instead of column here, I had to use the column. This is an excellent, Cage. Excellent. So somebody gets a round of applause. Excellent. It's over here. Take a look at this. This is a mistake. This has to be the comma. This has to be the comma. Okay. I'm going to correct it in a script, so that way you guys have a correct copy of the script. 2:10. I appreciate it. Thank you so much. Okay, now let me return and return to questions. Excellent. Okay, you mentioned that in the beginning you will send the materials covered today's presentation. Yes, you will have a presentation. I'll send it to instructor, and the instructor will do that. Yes, the recording will be available, of course. Are there limitations on file size? Yes, and there are also the limitations in part depend on your PC, on how much RAM you have, and on what else you have loaded in memory. I don't have the exact number, but I guess it depends on your PC as well. And here we are using the desktop version of R. We're using the desktop. There's also a server version. Well, this is something that advanced data mining classes later on do. You can use R on the cloud and R with databases, right? So, okay. Oh, I see. Julia's language is an open source. That's interesting. That's interesting alternative to R. I would need to do some reading on this. Thank you so much. This is going to be on my list. Okay. And thank you very much for pointing out about the sequence. I'll make sure this is corrected in the code. I just didn't save the correction. So let me see. Do we have more questions? So I'm so glad that this information was helpful. So you will have the slides. Oh, thank you so much, John. Thank you so much, John. So thank you, John. I'm gonna take a look at this site. Thank you. So I'm going to paste it here to make sure that I take a look at this. Okay. So let's see what questions we have. What was the presenter's name? I'm Yelena, right? So, and so you have the slides, the recording, our script, and a copy of the data file, right? That's what you'll have. Anything else? Questions? Well, question and answer session does not end. You may post your questions in a discussion, and your teacher, your professor and TA will answer it, right? So let's, if we have no question, I'm gonna call it a night, and I'm going to go ahead and stop the recording. So let's do meeting, and I'm gonna do. Oh, here it is. That's it. And so I want to thank everybody for paying the undivided attention. And thank you very much for staying on mute during the meeting. And thank you for excellent questions. I'll talk to you.